Scientists asked sleeping people questions. They answered.
Here is something that sounds like complete nonsense until scientists actually did it. A person lies fast asleep in a laboratory, deep inside a dream. Someone leans over the bed and asks them, out loud, a simple sum, 8 minus 6, and the sleeper answers correctly. Eyes shut, body still, by every ordinary measure unavailable for conversation. No mind-reading machine, no magic helmet, no tiny professor sitting inside the pillow. Just a question sent into sleep and an answer sent back. We like to think of sleep as a sealed room. You go in, the door shuts, and the world stays outside until morning. Traffic waits outside, voices wait outside, questions definitely wait outside. Because asking arithmetic to someone who is asleep is usually how you get ignored by both science and your spouse. But in 2021, researchers from 4 labs found that the room was not quite sealed. For a handful of strange nights in America, Germany, France, and the Netherlands, scientists managed to communicate with people who were asleep and dreaming. Not after the dream, during it. Which is a deeply inconvenient discovery for anyone who thought sleep was the one place where nobody could ask them maths. To understand how this happened, start with something you have probably experienced yourself. An alarm clock enters a dream. The beeping becomes a reversing truck, or a phone ringing in a shop, or a single, very rude bird that has apparently chosen violence. Your sleeping brain hears a real sound, but instead of waking you, it writes the sound into the story. That little trick is the whole mystery in miniature. The outside world gets a foot in the door. The harder question is whether the traffic can run both ways. Can someone send a message into a dream and get one back out? For most of the history of dream science, the answer seemed to be no. The only real way to study a dream was to wait until someone woke up and then ask what happened. This is already a problem. Dreams do not survive the trip very well. They fade the moment you open your eyes, like breath on a cold window. By the time you explain them, half the dream is gone. The surviving half has tidied itself into something that sounds more sensible than it actually was. You say, I was in my old school, but also it was an airport, and my dentist was a giraffe. And somehow, at the time, this felt completely reasonable. So dream research had a basic problem. You could not properly ask a sleeping person what was happening. And once they woke up, the evidence was already melting. It was rather like reviewing a play you never saw, based on the memories of someone who attended it while unconscious, which here was exactly the issue. Then researchers used a loophole: lucid dreaming. A lucid dream is a dream in which the sleeper realizes they are dreaming. The film keeps playing, but suddenly they know they are sitting in the cinema. It does not mean they can control everything. Dreams are not exactly famous for taking notes. The scenery wanders, characters refuse to cooperate, a hallway becomes a beach because your brain has apparently lost the minutes from the planning meeting. But a lucid dreamer can sometimes follow a simple instruction, and that is enough to build a telephone. Now there was one more problem. Which part of a sleeping person can answer? During REM sleep, the stage strongly linked with vivid dreaming, most of the body is held still. This is not a design flaw, it is a safety system. Your brain stops most of your muscles from acting out the dream, which is very considerate, because otherwise a dream about running from a tiger could become a real-life incident involving a bedside table and a deeply confused cat. But a few things are still available. Breathing continues, and the eyes can move. That is why REM sleep is called rapid eye movement sleep. So the eyes became the channel. The dreamer could not sit up and say, "Yes, professor, the answer is 2." But they could move their eyes in a trained pattern. Left, right, left, right. A tiny telegraph key behind closed eyelids. So that is what the researchers built. 36 volunteers took part across 4 laboratories. Before sleep, the participants learned response codes. They were trained to signal with eye movements or other small responses. They were also taught to recognize certain cues, like sounds, lights, or taps, as signs that they might be dreaming. Then the scientists waited, which is a sentence that sounds dignified until you picture it properly. A room full of trained adults, surrounded by equipment, quietly watching someone sleep so they could ask them subtraction. When the monitors showed the right sleep stage, the researchers gently sent in questions. Some were spoken aloud,
Some came as flashing lights. Some came as tones. Some came through touch. The questions were not rehearsed in advance. They included simple maths, yes or no questions, and counting tasks. The point was to make sure the sleeper was not just repeating something memorized. The sleeping brain had to receive something new, understand it, work with it, and answer. 8 minus 6. The sleeper's eyes move. Left, right. Left, right. 2. A correct answer from inside a dream. Which looks astonishing, until you ask the most important question. How often did it work? Because this was not a crisp telephone line. This was not two scientists having a tidy chat with a dreamer as if they had called customer support for the unconscious mind. Most attempts did not produce a clear answer. Sometimes there was no response. Sometimes the response was unclear. Sometimes the sleeper woke up. Sometimes the dream simply carried on being a dream, which is to say, not especially interested in laboratory protocol. But when the results were tallied, something remarkable remained. Across the study, about 18% of the questions received correct answers. Wrong answers were rare. That may not sound like much at first, but for a conversation with someone who is asleep, 18% is not a failure. It is a door opening. The researchers called it a proof of concept, a careful phrase, a scientist's way of saying, we have not built the dream telephone yet, but we did hear it ring. And the important part is not that the answers were perfect. They were not. The important part is that some sleeping brains took in new information from the outside world, held it long enough to process it, and produced a deliberate answer. That is the strange bit. Not reflex, not mind reading, not dream control. A person was asleep. A question entered. Thinking happened. An answer came back. One participant, who had narcolepsy and could enter lucid dreams more easily than most people, managed this again and again. For everyone else, the signal was faint. But faint is not the same as absent. And when the volunteers woke up, the story became even stranger. The questions had not always felt like laboratory questions. They had been folded into the dream. One person heard the maths problem coming from a car radio. Another experienced the question as a voice inside the dream scene. The outside world did what it often does during sleep. It disguised itself. The alarm clock became the reversing truck. The scientist became the radio. The lab became part of the dream's theater. Except this time, the dreamer answered back. You were not merely hearing the reversing truck. You were having a quiet word with the driver. And that makes the old idea of sleep as a locked room much harder to believe, because it was never completely locked. Some part of the brain seems to stay near the door, listening, not fully awake, not ready for a meeting, definitely not ready to discuss tax paperwork, but awake enough under rare conditions to catch a signal, to notice a question, to answer. This does not mean anyone can solve maths problems while asleep. It does not mean dreams can be controlled from the outside. And it absolutely does not mean you should begin interrogating sleeping relatives about where they put the car keys. The study was done under controlled conditions, mostly with lucid dreamers using trained signals and sleep monitoring. Most attempts still failed. The line dropped far more often than it held. But the discovery matters because it changes the shape of the question. Sleep is not simply off. Dreaming is not completely sealed away from the world. The sleeping brain is still sampling reality, still filtering sounds, still deciding what matters enough to enter the story. That may be why your alarm becomes part of a dream before it wakes you. Why a familiar voice can sometimes pull you gently upward. Why the sleeping mind seems distant, yet not entirely gone. And it hints at useful possibilities. One day, researchers may be able to speak gently into nightmares, or ask dreamers what they are experiencing before the memory dissolves, or study the sleeping mind while it is still inside the dream, instead of waiting for the dream to collapse into a confused morning report about airports, giraffes, and your old maths teacher. For now, the lesson is simpler. When you fall asleep tonight, the door does not slam shut. It softens. The room grows dark. The world becomes muffled. But somewhere in the sleeping brain, a small part of you may still be listening from near the curtain. and under the right strange conditions, it may even answer. If you enjoyed this strange little journey, subscribe and help us reach 1 million curious minds. There are many more weird facts hiding in plain sight, and we intend to bother all of them. The only question left is, which one we bother next?